Hello, this is Splicer called. So we basically just test this type in order. Flush, three of a kind, pair, high card. Oh, it's still in C++ because it's a new browser. What is it? Term flush. Three cards of the same rank. If any key then we return three of a kind. Two cards of the same rank, so it's basically the same. Actually, I only need to iterate over values. Values return, what's that? High card. Flush, three of a kind, pair. Okay. One for, I would need the default, so I better put a parenthesis here already. Actually, it's not enough. It's not one. So for an array of length x, the number of sub-arrays is and choose 2, something like that. Per length g, length list g, because it's an iterator for kgn. If k equals 0, default equals 0. I hope I put all the parentheses correctly. Why is it so slow? Did I do something wrong? Hello, hello. Okay, let me refresh the page. 690. Ah, it's not. Oh. Maybe I did something wrong here. It could be a plus. So if we plug in 2, it should be 3. So why is it 3? Wait, did I get it correctly? Be something like x times x plus 1 divided by 2. But why is it so slow? Okay, I'll look at the next one first. Give it nx in the system, return smallest nx. So basically we need a two-sided lookup. And that's it. Looks like so. I'll go with that implementation first. And wait, did I do something wrong here? Why is it like hanging? It shouldn't be. So self.d stands for like dictionary for lookup. RD stands for reverse dictionary. And change, okay, we first need to test. So this would be each one of this should be a PQ because we want to pop the smallest, but then we also need to remove things. So there are several options. Either we just go with the list and we sort it, or we use something heavier like a sorted container. So my guess is that some naive implementation with just 2 dictionaries should work. We'll see. Let's see if this, I put too few parentheses there. Try again. Should be 6, 9, and 0. I don't remember if the sum of an iterator, like empty iterator, is 0 or not. And this apparently should be like, I mean, I could do it the other way. If k equals 0, else 0, then I don't need to worry about like empty iterator. and it's still pending. I absolutely have no idea why. Okay, let me look at this one first. Shortest sequence of rows that cannot be taken from rows. Or rows. Okay, I need to see some examples to see how it works. What? I don't get this at all. Why couldn't 1, 4, 2 be taken from rows? Okay, maybe it's easier in Chinese. Let's see. Ah, okay. I get it. Like, we want the smallest sequence made from numbers from 1 to k that are not present in the array, which has nothing to do with dice. Okay, let me see if this is running. What? Okay, I have a bad feeling about this contest, but we'll see. So we can go with the PQ solution and like iterate through the, no. I was going to say and iterate through the PQ when it changes, but then then I need to implement a PQ that allows popping from arbitrary index instead of just using the heap cube class in Python. I need to think of something else. Or I just give up and use the sorted containers, which works, but I don't like it. Okay. Also, I don't remember the APIs. Sorted. Is it lowercase? Import sorted set. Okay, I hope I spelled everything correctly. And okay, 690. Let's hope that I got it right. Yes, great. It's slow. Change. So the easy case is if index is not in the lookup dictionary, then what we need to do is add the number. So the index equals number, and we need to add the index to the corresponding lookup. And we can return. Otherwise, the index is already in self.d. So if the number is not changing, then we don't need to do anything. else we first need to pop the corresponding index from the actually we need to pop something, but what do we need to pop? We need to pop this index from the original numbers lookup. So old number is index, and from the reversed lookup we need to remove. So remove is not entirely safe, but if the input is valid, we should be fine. Remove index and self.d. So basically this, I could have written it in a better way where I don't copy paste code, but well, I'm too lazy to refactor. And to find, we just need to get the smallest. Actually, I don't mean set, I mean like ordered. Wait, it is sorted set, I'm sorry. Sorted set smallest. This is awkward. Okay, is it min? Okay. Can I access it by index? I just don't remember. Index. I saw something earlier, but then I lost it. Okay, so I guess it's just the 0 term. Let's hope for the best. And in the meantime, I can think about this one. I don't want to check the rating yet because I feel like I'm pretty slow today. What's the range? Okay, it's pretty long, so we cannot actually, well, let me think. So the number of possible permutations is way larger than this in the given range, so okay, it's still pending. So what? Apparently a brute force solution would be just to generate all the combinations in order and test them all, which is going to be extremely slow because we're testing for subsequences instead of like subarrays. So is there some smarter way? Let's see. There are quite some people already passing this, so I guess it's not too difficult. And this is still pending. Oh my gosh. Why is it always pending today? So I'm guessing that it can be done kind of recursively or like in a DP manner, because for each subsequence of length like n-1, that's, I mean, for each combination that's of length n-1 that's already present in the sequence, we can choose like the earliest ending term, and then what we're asking is that all numbers are present after that, because all possible numbers form a permutation. So like once we collect like all numbers, like for example here, this is the latest position. I mean, from here on we have 1, 2, 3, 4, all of them. So which means that if we have a length 3 subsequence, then we're missing a 1. So it's bounded by this, at least. So in this case, it's bounded by 2. And in this case, it's bounded here. But we can also do it reversely, but this is, I mean, there could be test cases where we have all the numbers up front and all the numbers in the back. And then it doesn't really give too much, like, it doesn't really reduce the complexity, if anything. But still, we can count things, I guess. Okay, let me calm down. Oh, there's a 4, so like it's already filling the length 1 test. Okay, if it doesn't exist, can return -1. If I already forgot what I was doing here. But that was a silly mistake. So I didn't read carefully the description of the problem. 1, 2. Okay, good. How many people passed? Let's see. Okay, I should be top 100 at least. Like, not globally, but only on Leetcode China. So we can bisect, but it doesn't really help, because if we bisect on length, then for each length, it's still a lot of work to do. Unless we have an efficient way of deciding like if a certain length is feasible or not, which I'm not seeing right now, except that it's easy for length 1. Okay, what about length 2? If we're just thinking about like if it's possible with length 2, then so like imagine this is 3 instead of 4. So length 2 is already impossible because we don't have like a 2 followed by 1. I feel like there's something that I'm missing. So what I'm thinking is that, like, if we have a position where there exist two numbers that are separated by this position, then length 2 already doesn't hold. But what about length 3? Is there some way to generalize this? Or is the expectancy, is that like the answer is sufficiently small so we can like hard code all of them, and maybe we have a proof of that? But I also don't think that's the case. Like the reverse problem, like what is the, if we want to construct a sequence such that all possible combinations are contained in it, how would we do that? It's sort of like, I forgot the name, some encoding that contains all binary, which reminded me of Euler's Eulerian path. It shouldn't be that difficult. Okay, every time I refresh, it goes back to Chinese. Interesting. So another idea is that maybe there's an efficient way to test if a sequence is a subsequence of these rows, and then we just generate all the permutations. Or like it doesn't really make sense to cache the previous results because we're happy with the first result that we find. Except that like we still want to find the earliest occurrence. That sounds like an idea, like for we generate the permutations, the combinations by hand. We find its occurrence in the rows, like the earliest occurrence, and we cache it. So that for the next combination starting with this prefix, we just need to find the first each of these numbers after the previous endpoint. So effectively, what we need is that for each number, we need to be able to quickly find the next occurrence of any other number, which we can do by, well, can we? That's too much like complexity. Yes, we can bisect on the indices. Okay, I'm finally getting somewhere. How do I call it? Indices. So we're adding them in order, so it should be okay for rows. I think this should work. I hope I can like get it in one try bug-free. And this is x and y. I'm already worrying about the bisection part, but we'll see. I have the Python documentation open just for this purpose. Okay, what was I going to do? How do I like record the combinations? And is it fast enough? I'm just hoping that it's fast enough. Maybe I iterate over length just to clean up the like memory usage after each length, because we only need the previous length. Okay, I'm getting a bit skeptical, but we'll see. So memo is a dictionary that takes the tuple to the ending position. Earliest ending position. There's probably a better way of implementing this, but well. Range. So there's no way it would actually go that long, but well, maybe. Like if the rows are, like if the length of the rows, well, if it's very short, then it could actually reach, say if length of rows is 1. Okay. Then I actually need separate cases of L. Or I like pull this out and I can do the comprehension here. Or I don't, because it's tricky and I can early return if I don't come across any of the, okay, for val in range goes from 1 to 4 instead of 0. Not in indices. I only need to return the length. This was memo. Essentially, I'm sort of iterating through this memo. So I need a new memo to write down the new record for k, v, in memo.items. For, okay, let's call this pos because I need v for value in case I like mix up value in v. Value edge k plus 1. So I have another value which is like the previous ending value, which is like rows at position pos. This is like the index that I need to bisect on. And for values in range 1 to k plus 1, so it's in the indices because otherwise we would have returned here. So I'm going to check documentations. So what do I want? I want the first index that's strictly greater than this, which means that I want to find the last one that's like, I want to find the am I saying? So bisect left returns like the left side is strictly smaller, right side is strictly bigger. So we actually want the other one. So if we find the position where the left side is smaller than or equal to, I'm just worrying about the equal part apparently. And then the next one is guaranteed to be greater. So next equals bisect dot bisect. Which one goes first, array or value? Never remember. Array. And this is value. We're bisecting on pos. Wait, what did I need this on? What did I need this for? Do I need this actually? I don't need this. So what we're doing here is for this, for each of the new value, we're finding the next index, the smallest possible index that we can append to the previous combination. And like if it's out, then we can return L. I'm missing a +1, sorry. If next is greater than or equal to the length of indices, L, return L. Otherwise, what we're doing is that new memo and the tuple is like, we need to unfold K and append what is it again? Next. Not next, but like indices. Next. I hope I'm getting this correct. Do I need to put a tuple here or is it automatic? I don't remember. Actually no. Wait, what was the... From the tuple to the ending position. Actually, like I only need a set because the ending position is the last item in the tuple, right? Yes. Memo.add. No, wait, what? No, I need a tuple. Tuple is the combination because with each combination. Actually, I don't need the combination. I only need the length. Or do I? No, I need the combination. Just because the ending position is the same doesn't mean that, like, and the tuple is the value. Getting a bit confused. So here is the value. Yeah, that's correct. And this is the next position that we found. And this should be good. There, I forgot to set object is not. No, I forgot to change this back. Can I concatenate tuple to tuple? 60. Wait, where's line 60? 15. Not concatenating anything? Is it here? And I shouldn't reuse K. Tuple. And here's K. That's what it was talking about. And I should use tuple here. 2, 2, 1, 3, 2, 1. Okay, that's wrong. Let me just print the tuple value next. And close. Because tuple plus value next. Position is correct. Value is what? To find the next one. So I sort of know what's wrong. No, actually I don't. Let me print the indices just to check that I got this correct. 2 and 8, 2 and 8. So I got bisection wrong somehow. Maybe I just don't need +1 here. But it should break at 3. I don't know why it isn't. And, yeah. Oh, because I never reassigned like memo to new memo. That's why. This is dot next, not dot next. Should be dot like of, and this is value at next. Well, let's see. Fingers crossed. Okay. Just want to see like how many test cases I passed. Then. Whoa. Then I must have done something wrong. I also lost the previous like submission, so I have to get another wrong answer to get the test cases. Let me think. All right, I'm going to pause the recording for a bit because I'm stuck anyways. And I hope I can come up with something and come back to it later.